we are going to talk about the square root family. Remember our caret, root, square root? Yeah. Okay, so the transformation we're going to look at today is called a reflection. So if you remember from that function family activity that we did, the parent graph looks like this, and I want you to notice that it is located in quadrant 1. The entire graph is in quadrant 1. What's the domain for the square root function? What are the allowable x values? Yeah, Bella? Nice job. 0 to infinity. How about the range? Do we have a lowest y value? Yeah, Andrew. It's 0 to infinity again. It just doesn't increase as quickly as it goes up. It just goes up kind of slowly there. Now, let's make a guess here. How do you think the graph will change if we make it y equals negative square root x? What do you think that's going to do? You think it'll be the opposite way? Let's find out. Okay, so now that negative is in front. Okay, so if I plug negative 2 in, that's still undefined. If I plug 0 in, that's still 0. Excuse me. So if I plug in negative square root 1, that's negative 1. If I do negative square root 3, that's negative 1.732. If I do negative square root 4, that's negative 2. And negative square root 9 is negative 3. So let's plot these. So I still have 0, 0. I have positive 1, negative 1. 4, negative 2, and 9, negative 3. How did our graph change then? Nice job. It's a reflection over the x-axis. So our y values are the opposites, right? Well, let's maybe squeeze that in up here. The y values are opposite the y equals the square root of x. Ooh, what quadrant is the graph in now? It's in the 4th, okay? This is now in quadrant 4. And just in case you need the refresher, it goes quadrant 1, then it goes counterclockwise, 2, 3, and 4, in case you need a quick refresher. Ooh, let's talk domain and range now. What's the domain? What are my allowable values for x? Becca, what do you think? Well, it's the same, right? It didn't change. It was 0 to infinity because I'm talking about describing the x values. This does go x is 0 and then it moves to the right. So that does go to positive infinity. Now, I think what you were thinking about is let's look at those y values. You see it has a high y value of 0, but it goes down forever. So when we write an interval notation, the smaller number always comes first. Now, doesn't this make sense? Because what we wrote down is the y values are the opposites. So instead of it 0 to infinity, it's 0 that went down to negative infinity. But then we're just going to put it in the proper order. So this transformation is a reflection across the x-axis. All right, let's keep going. Now what if, instead of the negative being in front of the function, what if the negative is inside with the x? So let's kind of play here a moment. So what that means is when I plug in, this becomes y equals the square root of negative 2. That's allowed, isn't it? That's actually the square root of 2, and that's 1.414. Uh-oh, then what happens when I do y equals the square root and I make it negative 1? That's undefined. All of these are undefined. So I need some new points that I can actually do. Let's do negative 1. So that's y equals the square root of negative 1. What's the next nice number I should try that'll work out nicely? Yeah. Yeah. Well, won't it be negative 4? Yeah. Let's do negative 4 because that's the square root of negative 4. So that's 2. And then let's do negative 9, and that's 3. So I can plot 0, 0, negative 1, 1, 1, 2, 3, negative 4, 2, and negative 9, 3. Oh, so now do you notice this is in what quadrant? That's in quadrant 2. What kind of reflection is it? It's not across the x-axis. Yeah, isn't that weird? This is a reflection over the y-axis. So what it did is it took all of the x values and made them opposites. Okay, it took the x values and made them the opposite of the x values. So what's the domain now? Yeah, Davey? Yeah, there we go. Do you see this graph is 0 and then going left forever? Well, then the way we write interval notation is the smaller value, comma, the bigger value. What about the range? What's the range here? Yeah. 0 to infinity. All right, so I want to pause here and see if we can't make a connection. When we replaced x with negative x, that changed my domain from the parent graph, but it didn't affect the range. When I put a negative out front, that didn't change my domain, it changed the range. Okay? So this transformation is a reflection over the y-axis. Now let's do one more where we do both, a minus out front and a minus underneath. So let's make a table. I can plug 0 in and that's 0. Can I plug in positive 1? What happens if I plug in negative 1? You get a square root, or excuse me, you can't plug in 1 because then that's the square root of negative 1. So I actually need to plug in negative 1 because that's going to give me negative the square root of negative 1. So that's negative square root 1, which is negative 1. Do you see that? I could not put x as positive 1 in because I'd have a square root of a negative. And up to this point in your math career, you've been told you cannot do that over the set of real numbers, which is true. Later, we are going to find out about an additional number system that includes imaginary numbers. Okay, let's plug in -4. So that's -2. Let's plug in -9. And then let's plot those points. All right, let's plot those points. So I have 0, 0. I have -1, -1, -4, -2, -9, -3. Okay, so the domain is -infinity to 0, and the range is -infinity to 0. Now, when you do both, this is actually called a reflection with respect to the origin. Hopefully you remember a little bit of this from geometry. Two reflections result in a rotation. All right, so that was just experimenting. So now we're going to write it formally. In the blue box here, a reflection is a transformation that flips a graph across a line, creating a mirror image. When you have y equals f of x, the graph of y equals f of -x is a horizontal reflection across the y-axis. If you replace y with -y equals f of x, or you have negative f of x, that's a vertical reflection across the x-axis. Therefore, what we experience with the square root function will be true of all of our functions. So this is really, really cool. Whatever, of these parent functions we're looking at, it's going to apply to every other one that we ever did. So if I look at y equals x squared, let's do a real quick little sketch. You have 0, 0. If I plugged in 1, you'd get 1. -1 is 1. 2 would be up at 4. -2 would be 4. So you can do a rough little U shape here. Okay, anytime you are asked about a function, you should make a sketch of it, even if it's rough, okay, even a rough sketch. So, if y equals x squared is our parent function, anybody remember what was the domain? How far left and how far right does this parent graph go? Yeah, Davey? Yes, it goes left forever and right forever. What's the range? What's my up and down? Wyatt? Nice. 0 to infinity. Now, I would like you to take out or go to Desmos, or take out your graphing calculators for those of you that have graphing calculators. And what I'd like you to do is put in y equals -x squared. And those of you with graphing calculators, if you don't know how to graph, just raise your hand and I'll come around and I can help you. What you do is you press menu, do a new doc, and pick graph or sketch a graph. I'm going to go ahead and pull up my Desmos here. Yes, y equals -x squared. So I'm going to do y equals -x squared. Oh, what does that do to the graph? It flips it how? over the x-axis, right? So it says make a rough sketch of what you see. So it looks like this. So we would say, and in Algebra 2, we don't use the word flip, okay? We use reflection. It's a reflection, and then we say how. We would say it's a reflection over the x-axis. Now, on your graphing calculators or your Desmos, graph x squared and in a parenthesis. It makes a difference, okay? Y equals negative x squared. So I'm going to go back to my Desmos here. I'm going to put the parent graph first. And then do y equals parenthesis negative x close parenthesis squared. Now, I don't see anything different, do you? But something did happen, okay? Something did happen, and let me explain why we can't see it. So, it says make a rough sketch of what you see. Well, it looks like the same. However, what this graph did, it took 1, 1, and it took and made it the opposite, and so it moved it to the other side, and I couldn't see it. So it took everything on the right and flipped it to the left. It took everything on the left and flipped it to the right. But because that's the same graph, we can't really see it. But really, it's a reflection over the y-axis. And due to the symmetry, it's hard to see. All right, then what would y equals negative parenthesis negative x squared look like? Well, if you did the negative inside, it just flips the left side to the right, so it looks like the original. But then the negative out front flips it upside down. So this negative does a reflection over the y-axis, and this negative does the reflection over the x-axis. All right, number 2. Graph f of x equals x cubed on your device. Which of the following functions has a graph that looks the same? Make a prediction before you actually put it in the calculator. Which one of those 3 do you think would be the same? All right, so I'm going to pull up my Desmos and knock everything out, and I'm going to do y equals x cubed. And I would do them kind of adding one in one at a time and then removing it. So if I put the negative out front, oh, isn't that kind of cool? It looks like 2 parabolas together, doesn't it? So I like to do my arms, and at some point we'll do some math aerobics. So this is x cubed. Putting a negative out front, look at this, mine's in blue. Watch my arms here. So this is x cubed. It did this. When it reflected, putting a negative out front, that reflects this piece, the green one down here, reflects it over the x-axis, and this piece reflected up. So I went from this is x cubed to this is negative x cubed. Okay, x cubed, negative x cubed. So let's go back to that. So here's x cubed. then watch. This one is f of x, or wait, I should rewrite that. Okay, this should be y equals negative f of x. All right, now let's go back to Desmos, and I'm going to knock that one out. And let's do y equals parenthesis negative x cubed. Oh, isn't this interesting? Doesn't it look identical to the other one? The second one we just did? But guess what? Because I replaced the x with negative x, this one, now the green one got reflected over the y-axis. So it's different. It really is different, but it looks the same. Like it has the same net effect. And then this piece got reflected across this way. Where the other one, it reflected down and up. Now it's going across. So that's interesting. So now, let's draw this picture. So this is y equals f of negative x, and maybe I need to go back. This is a reflection over the y-axis. This one is a reflection over the x-axis. So then let's find out the third one, f, or y equals negative f of negative x. So I'm going to do y equals negative parenthesis, negative x, close the parenthesis, cubed. Oh, it looks like the original graph, doesn't it? Because what's happening is it reflects it over the y and then back over the x. And then it's mapping back onto itself. Now those of you, we can't put it on the iPad because it's going to rotate. But if somebody at your table has their graphing calculator on this one, or the y equals x cubed, can you take your graphing calculator, and I want you to turn it upside down. Okay, take it and just rotate it completely upside down. What do you notice when it's turned upside down? Look at the graph and compare it to the original. What does it look like? It looks the same, right? When you can do that, because this is going to lead into my 3.6, so we're going to spend 2 days on this lesson. We're going to do 2 days on 3.6. Then we're going to do some review Friday, Monday, and then we're going to have a unit test on Unit 3, okay, next week. But one of the things we're going to tie into is this is called origin symmetry. When you can take your graph, when you turn it upside down and it looks like the original, that is what we call origin symmetry. All right, so here, let's make our sketch. And this is y equals negative f of negative x. All right, that concludes the notes. Yeah. Mm-hmm.